All right, everyone. This video is for lesson 2.4. It's called Do You Have 5 Seconds? So it's connecting the previous lesson we did where you tried to stop the stopwatch as close as possible to 5 seconds um, and then recorded them all on the board. And we got a distribution and we found out that the distribution is indeed symmetric like this, approximately normal like this. So for this lesson, we're going to look at data from last year that I had because it worked out pretty well. For that data, the times were approximately normal, which means they followed your nice normal bell curve with a mean of 5.02 seconds and a standard deviation of 0.10 seconds. So we're going to label the values for the standard deviations. So the mean, and sometimes the mean will be a mu, will be here, it's 5.02. And then I'm going to count by 0.10s. I'm going to add one standard deviation plus 0.10, which would be 5.12. And then another one is 5.22. And then the third one we'll label at the far right is 5.32. When you go the other way, it'd be 4.92, 4.82, and 4.72. And we're learning the last couple days that really, once you go past 3 standard deviations in either direction, there's really not much data out there. And you can see that because the curve is pretty much coming down to a value of 0 on both sides. Most of the data is in the middle. All right, what value is 1 standard deviation below the mean? Well, that's what we just did right here. That's 4.92. What value is 1 standard deviation above the mean? That would be 5.12. So simply here and here. And we got that again by adding and subtracting 0.10 from that. Okay? Estimate the percent of values within 1 standard deviation of the mean. So I guess I'm getting at estimating, like, what do you think this is in between all of this? What do you think this all is in here? You know? What do you think? It's 1 standard deviation either way. So take a minute right now, take a guess. Don't wait for me to do it. Guess yourself. I'm going to guess, I don't know, 70%. Okay? And we're going to repeat this with 2 standard deviations away from the mean. So here, in case you're wondering where I'm getting these numbers, let's do a calculator. Can I make it more visible? There we go. So 5.02. Oh, it's not responding. Hold on. Okay. Sorry, I'm having difficulty here. 5.02 plus 0.10 plus 0.10. In case you're wondering really where I'm getting these numbers, right over here, plus 0.10 plus 0.10. Okay. So that would be 2 standard deviations above. Oops, that would be above over here. And then 5.02 minus 0.10 minus 0.10, in case you want to see the calculator steps, 4.82. Okay, so now what percent do you think is that? So now I'm adding in, if I'm going to keep highlighting, I'm going to add in some more. So it's the green plus the red. Okay, the green plus the red. What do you think? And as you're looking at this, right, remember this is a density curve. So the area under the curve is 100%. So what part do you think the green and the red make up together? It's pretty darn high, okay? And we're just going to throw a number on it of 95%. Okay? And then we'll continue onward in this manner and do 3 standard deviations. So that would be the 4.72 and the 5.32. That's these two numbers here and here. What percent is there? So if I highlight some more, what color do I want to highlight here? Let's go like a blue. So that's these little blue tails down here, okay? Looks to me like that's pretty much covering the entire density curve, right? So I'm going to say my estimate is 100%. Okay, and we'll get a little bit more particular and exact here when we use the applet, okay? So the applet, bring that up, and we're going to go to the normal distribution under probability right there. This is so cool. You guys are going to like this. And then we're going to find the actual percentage within 1 standard deviation of the mean. Look at this. All I have to do is type in 5.02. 5.02 and a standard deviation of 0.10, and then plot the distribution, and there it is. Look at that, and that's exactly what we have on the right side there. And then I can find the area between any of these just by using the left boundary and the right boundary. So let's try to do this one here. So the left boundary was 4.92. The right boundary would be 5.12. And then calculate the area, and it even shades it in for you. Look at that. And the exact percentage that it's telling me is 68.27%. You know, so up here I threw out a number of 70%, and I kind of knew where I was going. So here, on your own, you could pause the video and you could try to do these two, or just follow along. And then hit play when you're ready. So let's just do it again. Now for 2 standard deviations, my left boundary is 4.82. And my right boundary is 5.22. And calculate the area. And we have 95.2, 95.45. I kind of cheated earlier because, well, I knew where I was headed. And then the third one. We'll go from the very lowest to the very highest. Calculate area. Look at that. Almost 100%. Okay? 99.7%. All right. Oh, there we go. All right. Next question. What percent of the stopwatch times are less than 4.82 seconds? Okay. Let's see if we can do these questions right here. Let's see if we can do these with no applet. Okay. So I'm gonna just say, forget you. I'll come back to you later. So let's do no applet here. Okay. What times are less than 4.82? Well, 4.82. Okay. Here's 4.82. So I just want this down here. Just want that little blue area. That's it. Okay. Well, what is this part in here? That is, we're going to start to estimate these and not do such particular decimals. So these are 34s because together that made my 68.27, okay? This is a general rule of thumb. We're not going to care about those decimals, okay? If I say no calculator, you'll just think, oh, those two green parts are each 34 and they make 68. And then the two pink or red parts have to add up to make, we're going to make this 95. Okay, so calculator time real quick. So what is 95 minus 68? That is 27. So meaning, right, I took 68 away from this. I knew that this whole thing was 95. So the two red areas make 27 combined. So if I divide them by 2, it tells me the area of each red area. So the red is each 13.5%. If you're still not tracking with me here, do this. 34 plus 34 plus 13.5 plus 13.5 is 95. So if you're within 2 standard deviations of the mean, that will capture 95% of the data. Okay? Where am I going with all this? So in other words, these two blue tails are what's left over if I get rid of the middle 95. So remember, it's a density curve, so everything adds up to 100%. If I take away the 95, that means that this little tail and this tail combined make up 5%. So then if I cut it in half, that tells me what this tail is down here. So this blue tail is about 2.5%. And this blue tail is, again, about 2.5%. So to answer the question, the math we did, if this helps, is we did 100 minus 95, and we got 5, and then we cut 5 in half, and we got 2.5%. Okay? How about this? What portion of the times are between here and here? So now that I've got these percentages labeled, it's a little bit easier. So what's between 4.92 and 5.22? So it's this right here. So I can do 34 plus 34 plus 13.5. That's one way to do it. I can do that over here. 34 plus 34 fig, like that. Okay, or I could think again. I wanted to add up this, right? Well, didn't we just a moment ago figure out that this was 95%? And then I could just subtract 13.5. So there are definitely more than one way to go about this, okay? Either way you go about it, you're going to get 81.5%, okay? We're doing general rules of thumb again. We're kind of ignoring some of these decimal points. We're doing 68, 95, 99 is a general way to say it. What is the stopwatch time that is at the 84th percentile? Now, this 84 did not just get invented out of nowhere, okay? It is, if you think about it, let's look at this. What is this? The left half, well, that's 50%, right? 50% of the data is below 5.02 because it's the center. But what's 50 plus 34? Well, that's 84, right? 50 plus 34 is 84. And hey, well, that's what I'm looking for. I want the 84th percentile, okay? So in other words, if I go one standard deviation above the mean, this will be the 84th percentile. And what was that? For our distribution, it was 5.12 seconds right here. And again, how did I get, where did this 50 come from? Half the data is down here. That's 50%. And then this brings me to 84. So this mark right here, 5.12, is one standard deviation above the mean. It is also the 84th percentile. So there you go. There you have it. Okay. So what we're getting at here for your learning targets, okay? Learning target number 1 is something called the empirical rule. And I'm going to try my best to sketch this, okay? So you can skip forward if you're already catching on. If you're like, I'd like to hear if I explain this, then just stay for a little bit longer, okay? So there's my normal curve. I'm going to draw and label the mean in the middle, and you can skip forward if you don't want to watch me do all this. 1, 2, 3, and 1. Let's try to make these look the same. 1, 2, and 3. Okay. And so here's your notation, right? Mu is always the middle. That is always the mean. Okay. And then we have mu plus 1 sigma, 1 standard deviation, mu plus 2 sigmas, and mu plus 3 sigmas. Okay. And then likewise the other way. Minus 1 standard deviation, minus 2 of them, and brain fart, minus 3 standard deviations. Okay. All right. And here's what we've essentially learned. The empirical rule is oftentimes called the 68, 95, 99 rule. Or sometimes people get more specific. They'll do 68, 95, and then they want to be more accurate, so they do 99.7. They're both uh, fine. If you want to be more exact, you do the 99.7, which is what I'll do when I label this, okay? In fact, maybe I'll just ditch this one and say forget it. I'll go more accurate, okay? All right, so essentially within 1 standard deviation of the mean, that'll be from here to here, is 68% of the data. Within 2 standard deviations of the mean, you have 95% of the data from there to there. Okay. And then if you go all the way over, let's try, I don't want that to be, I want green. All the way over, 3 standard deviations. Let me lift that up a bit. That is almost all the data. That is 99.7% of the data. This is something that is just so critical to the entire course, okay? It's just so big. So, like, if you are 3 standard deviations away from the mean, you're an outlier. That data point's an outlier, and it's really unusual to be 3 standard deviations above or 3 standard deviations below, based on your z-score or the number of standard deviations you are, or I shouldn't say you, number of standard deviations a data point is from the mean. Next learning target. This is a little bit apart from what the rest of the notes have been. This is assessing normality, meaning how do you know if data is normally distributed? Okay, how do you know? And there's really a couple ways to do this, is to create the box plot or the histogram, or the dot plot, or maybe I'll say stem plot. In other words, make a plot, right? And then um, is it um, peaked in the middle, and symmetric? Okay, which we did that, you guys. When we did originally, remember when we were tossing the pennies and we were rolling the dice and we were doing the stopwatch, the 5 second stopwatch, this is what we did. We created the box plot or a histogram. I think a lot of you did dot plots. And then you looked to see if it looked like this shape. Was it peaked in the middle and is it symmetric on both sides? If it is, that's a pretty good indication that we have what we're dealing with is a normal distribution. And then the last one, which takes a lot more time, is to check if the data fits the empirical rule. Okay, this takes lots and lots of time. So what I mean by checking the empirical rule is you'd have to look at your data, you'd have all these numbers. If you still had the numbers written down, like somebody was 5.04, somebody was 4.6, somebody was stop the stopwatch in 5.11, and dot, 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 right? You have all the data. You would have to, let's say the class had 26 data points, okay? To check the empirical rule, you would have to, um, you'd have to count up how many are within 1 standard deviation of the mean. Looking at your numbers way up here, you'd have to say how many data points are between here and here, and you'd have to count them up. It would take time. You'd say like, nope, yep, nope, yep, and so on. I'm just kind of making that up. And then you'd have to divide. Let's say you found that there were 17 data points that fit. Well, then you'd say, well, 17 divided by 26 is 65%. And, is that, you're going to have to decide for yourself, is that close enough? Close enough to what, Feig? Close enough to 68%? Yeah, it's pretty close. It's not terrible. And then what about the 95%? So you count up how many are within 2 standard deviations. This one, this one, not this one, this one, and so on. And that percentage should be close to 95. And then almost all the data should be within 3 standard deviations. You might have like one that's not. If you check all three of these percentages, then they're all pretty close, then that's pretty solid proof that this data is normally distributed. All right, folks, thanks for watching. Have a great time doing your homework.